Okay, everybody, so again, this worksheet should have been handed out to you by the sub. I'm just going to kind of go through these ones. You'll notice these are rational, which means those are the fraction ones that you see going down here. And radical, those are the ones down here when we have the rational exponents or the square roots on this stuff. So let's go one at a time on this first one right here. Before I try and solve this equation, I want to break apart the top. So you can see that the top becomes x plus 6 and x minus 3. And this x plus 6 should kill that x plus 6. So then you're left with 4 equals x minus 3. And if 4 equals x minus 3, then x equals 7. You'll check 7 is 7 an issue with the domain, where the issue in the domain is that x cannot equal negative 6 because of the 0 right there. So we should be good on this problem. And that's all we need to do. On this next one, this would be factor the top here, which gives you x, looks like x plus 6 and x minus 5. This x minus 5 kills that x minus 5, and you're left with x plus 6 equals 11. Subtract your 6, and you get x equals 5. You're like, yay, that works just like the x equals 7 worked. However, if we check 5 back in our original problem, you'll see that 5 minus 5 is not in the domain, so x can't equal negative 5, which means 5 technically is what we call an extraneous solution. And one more time, that's a solution that works in the equation that you solve, but not in the original problem. I'm going to go ahead and do this one right now. So I can see that I have an x, and an x on each one of these terms, so I can factor out an x. That's called factoring like a dentist, correct? So I pull out the x and I get x squared plus 4x minus 12 there on the top. And you can see that this x right here will kill this x right here. And now I've got 3 downstairs. So I'm going to go ahead and cross multiply. So if I do this cross multiplication, I get x squared plus 4x minus 12. And I do this cross multiplication equals 6x plus 12. Now some of you might be thinking crisscross smiley face, but remember crisscross smiley face is when the thing in the middle right there isn't an equal sign, but it's a plus or a minus sign. So if it's an equal sign, it's just considered a proportion. And we cross multiply, rewrite the equation, and solve from there. So minus 6x and minus 12, minus 6x and minus 12 gives me a new equation of x squared minus 2x equals 0. Because, oh, sorry, minus 24, what was going on with that? I almost lost you. So with this minus 24, factors of 24 that differ by 2 are 4 and 6. So I get x minus 6 and x plus 4 equals 0. And if I'm solving that quadratic, then it means that 6 and negative 4 happen to be my solutions. Okay, so 6 and negative 4. You could try them back in the original problem and see if they work. We know that domain-wise, 0 is the only thing that I'd have an issue with. So 6 and negative 4 probably both work. Okay, so I have one like this. This is something new for you guys. You haven't had one of these things before. But I need to get rid of my denominator. And just to make sure we're clear on this, this should say negative 6 over x, so that isn't a long fraction. There really is a negative sign out in front. So I need to multiply the entire problem by x to get rid of this denominator right here. So when I do the x to the first term, I get x squared. When I do x to the second term, I get negative 5x. And when I do x to the third term, the x that I multiply into the top right there kills off the one that's on the bottom, and I get equals negative 6. This is a quadratic equation. I want to set that equal to 0. So I'm going to do x squared minus 5x plus 6 equals 0. This factors into, looks like x minus 2 and x minus 3 equals 0, which means my solutions are 2 and 3. So x is equal to 2 and 3. None of those are issues with the denominator over here. You can go ahead and check them to see 2 minus 5 is negative 3. 6 divided by 2 is 3, and there's a negative, so a negative 3 and a negative 3. It works. Turns out that both of them do, so I don't really have to go any further on that problem. This one right here is really long. I'm going to save a little bit of space with it. I'm going to skip it for right now. I'm going to go down to one of these ones down here. So I'm going to go ahead and solve number 6, and I'm trying to solve for x. So we know that every time I solve for x, I need to isolate the x. So step number 1, I'm going to add 7, then I get x minus 4 to the 1/2 power equals 14, because I added 7 to both sides. Now how do I get rid of a 1/2 power? Well, 1/2 power is the same thing as a square root. So I'm going to square this side, I'm going to square this side, and I get x minus 4, because the squaring killed the square rooting, or the power to a power rule means I multiply it, and 2 times 1/2 is 1, so it just goes away. Equals, first time on this sheet I need to pull out my calculator. I'm going to go ahead and do 14 squared, and I get 196. And then I add 4, and I add 4, and x equals 200. Final answer on that one. Down here, I'm trying to solve this problem like this. Blow that up just a little bit so you can see it a little bit better. So I got the square root of 36x equals 4 times the square root of x plus 5. Whenever I'm solving a radical equation, I want to try and isolate the radical. And unfortunately, this one's isolated, but this one's got a 4. If I move the 4 to the other side, it just makes it so that that one would have it. So I'm just going to go ahead and square both sides from the very beginning. And as long as I do both sides of the equation, it should be okay. So that leaves me with 36x, because the square killed the square root. And over here, you got to be a little bit more careful. It's an equal sign, and I got to square both things. So I have to square the 4, which is 16, and then I got to square the square root of x plus 5, which is x plus 5. So now I get 36x equals 16x plus, what is that, 50, 5 to 6 is 30, 80. Awesome. Subtract the 16x, subtract the 16x, and I get 20x equals 80. And it looks like a big old x equals 4. Sorry, can't make too bad for you. Pull that back up again. So I got an x equals 4. Good. I'll stretch this out as I'm getting to the bottom of the paper so they can still move this around. On this next one, again, a goal is to isolate the radical, which means I'm going to go ahead and square this side and square this side. This one, squaring the square root of an x plus 10 equals x plus 10. Over here, I got an x minus 2 squared. I have to FOIL that, so that's x squared minus 4x plus 4, because x minus 2 squared means x minus 2 times itself, x minus 2. This is a quadratic. I need to set that equal to 0, so I'm going to do negative x and minus 10, negative x and minus 10. And I know I'm going a little fast, but I don't want this video to be super long, so you can pause it and rewind it and listen to whatever you need. X squared, that kills that, that kills that. Negative 4x and negative x is negative 5x, and 4 and negative 10 is minus 6. Awesome, so now I need factors of 6 that differ by 5. And because that's a minus sign, they need to, one needs to be positive, one needs to be negative. So I'm pretty sure that even though I had a 5 and a 6 up on this one, and I used 2 and 3, that on this one down here, I actually need to use x minus 6 and x plus 1 equal to 0. This will give me a 6, this will give me a negative 1, and I check them. So let's try it. 6 into here, 6 plus 10 is 16, square root of 16, that gives me a 4. And then 6 minus 2 is also 4. So check, that one is real. Happy about that. Let's check negative 1. Negative 1 plus 10 is 9, square root of 9 is a 3 on this next one. And negative 1 minus 2 is a, ooh, that's a negative 3. 3 does not equal negative 3, so negative 1 is an extraneous solution. Good. Last one down here, 4 times x minus 3 to the 2/3 equals 8. Trying to get the x by itself, which means I got to remove everything else around that. So divide by 4 first, divide by 4 first. and I get x minus 3 to the 2/3 power equals 2. Trying to get rid of a 2/3 power, to get rid of a fractional exponent like that, I have to raise it to its reciprocal. So in other words, to get rid of a cube root, I'm going to cube it. To get rid of a squaring, I'm going to square root it, and that's what those two things do. Do it to both sides. And now I have x minus 3 equals 2 to the 3rd power is 2 times 2 times 2, or 8. And then that's the square root of 8. So yes, handy dandy little calculator, need to pull that out. So square root of 8 should be 2.828. 2.828 that's good enough. 4 decimal places. Then I add 3, and I add 3, and I get x equals 5.8284. We've been really pushing this in the class, so I'm going to go ahead and pull this next to you so you can see that. I'm going to add the 3 to this, enter. I'm going to store that in x so that we have that as a thing to be able to go with. And then I'm going to retype my equation. That's this equation right here. So 4 parentheses x minus 3 close parentheses raised to, and remember old calculators, you got to put this in parentheses, so I'm going to go ahead and do it for it anyways, even though I don't need it on this one. Raised to the 2/3, and when I hit enter, cross my fingers that it's going to say 8, and whammo, it is 8. So solution is that one right there. Okay, so that takes us to this problem right over here. Again, all of these are ones that I'm giving you examples on. I'm hoping that you can do the problems that are going to be in the book. So how do I go about doing this? The first thing I'm going to do is I'm going to factor this thing over here on the bottom. And this bottom one factors like this. What I got? 18's factors are 9 and 2. So x minus 9 and x plus 2. This one's factors right here are, it looks like, x plus 2 and x minus 1, x plus 2 and x minus 1. And you can see that both of these fractions already have an x plus 2 on them. So I really just need to multiply this one over here by an x minus 1, and this one over here by a x minus 9. So here we go. So x minus 1 goes to this one, and x minus 9 goes to this one. And because this might mess you up, I really am multiplying everything by this and this too, and this one over here gets an x minus 9 and an x plus 2, and maybe this will help out more. So I'm going to multiply both equations by that, so I did it to both sides of the equation. Here's my equal sign, so that's my separator. So this x plus 2 kills that x plus 2, and that x minus 9 kills that x minus 9, so I'm left with x minus 1 times 2x. So I'm going to go ahead and write that right there. That would be 2x squared minus 2x. And that. Over here, this x plus 2 kills this x plus 2, this x minus 1 kills that x minus 1, so I'm left with x minus 9 times 6x. So that gives me 6x squared minus 54x. And that's kind of scary looking stuff, but it's quadratic, and I want to set it equal to 0. So I minus 2x squared here, and I add 2x, and I minus 2x squared here, and I add 2x. And now it gives me 0 equals 4x squared, yeah? And then what is this? Looks like minus 52x. Ooh, 4 goes into both of those, and x goes into both of those. So now 0 equals, I'm going to pull 4x out. So I got 4x times x minus, if I do my math right in my head, x minus 13. Okay, so either this is 0 or this is 0. So that means I have a 0 at 0, because that would have to be 0. And I have a 0 at 13. I can go ahead and check those back in the original problem, but guess what? They do both work. So that's my final answer on that. And some of the problems that I would like you to try out of the book are just like